In section 4.2, we need to be able to find the least squares regression line, and we can do that fairly easily using our Casio. So one of the problems from your homework is, suppose a professor records the number of days absent and the final exam score for the students in his class. Use this data in the table below to answer questions A through D. Our first question is asking us to find the least squares regression line, treating the number of absences as the explanatory variable and the final exam score as the response variable. We're going to go through the same process that we did in section 4.1 to find our correlation coefficient. The reason we're doing this is that there has to be a linear relationship before we go and find the least squares regression line. So to do that, again, we're going to go mode and then 3 for stat, and this is 2 variables, so 2 for a plus bx, and then we're going to enter in number of absences, so 0, 1, 2, 3, and 4. And for our y, we're going to enter in the test scores. So we've got 84.5, 85.3, 80.2, 77, and 66.8. Once we've entered those in, we're going to hit AC, go to Shift, number 1 for our stat menu. Under regression, which is number 5, we're interested in 3, or R, our correlation coefficient. After we do that, we're going to hit our equals, and we get that R equals a negative 0.923, and we're going to round that up to 5. So we've got 5 pieces of data. So we're looking here with n is 5. So we need the absolute value of R to be greater than 0.878. Well, we have the absolute value of negative 0.9235 is greater than 0.878. So indeed, we do have a linear relationship. Once that's established, then we can go through the process of finding the least squares regression line. So remember, the least squares regression line is y hat equals mx plus b. And I'm putting mx plus b because this is our standard slope-intercept form, where m is our slope and b is the y-intercept. I do want to make a note, though, that whenever we're going through our calculator, we had a plus bx for 2 variable. So we need to be thinking about this a plus bx, because what that means is that b is going to be our slope, or our m, and that the a is going to be our y-intercept, or our lowercase b. So it's in backwards order from what we're used to. So to do that, we're still going to go through the same process of entering in the data. Because we've already entered in the data using these first 2 steps, now we're just going to go through and find our A and our B. I prefer to find B first. So we're going to have y hat equals, and then we need to figure out our B. So to do that, we're going to go to Shift 1. This is our stat menu. We're interested in our regression line, so number 5, and then our b, so that's number 2, and then hit equals. So we get b is a negative 4.37. So we have negative 4.37x, and now we need to find the a, or our y-intercept. Now, to get our y-intercept, or using the a plus bx, we're looking for that a. We're going to again do Shift 1 to get to our stat menu. We're interested in regression, so number 5, and then number 1 for the A, and hit equal, and this gives us 87.5. So we're going to have plus 87.5. So our y hat equals negative 4.37x plus 87.5. Next, let's talk about what this slope means. So if we come back up here and look at what we're talking about, we're discussing the number of absences, and this is impacting the final exam score. So if we were to graph this, we would have our absences down here and our score over here. So the slope is the rise over run, or the score per absences. So having negative 4.37 means that we expect somebody's score to decrease by 4.37 points for every absence that they have. Now that we've discussed what the slope is, let's also discuss what the y-intercept represents. Remember, the y-intercept is going to be the point 0, 87.5. Again, keeping in mind that we have our absences along the x-axis and then our score along the y-axis, then this would be that somebody with 0 absences is going to have a score of 87.5 on their final exam. Now, let's use our y-hat to predict the score for somebody that has 4 absences. So to predict the score of somebody with 4 absences, we're just going to plug 4 in for x here. So we're going to have y hat equals negative 4.37 times 4 plus 87.5. So that's going to be negative 4.37 times 4 plus 87.5. And this gives us 70.02. So 70.02 is the predicted value. But if we come up here, we can see the actual value. So the actual value is 66.8. So we have overestimated the actual value, meaning that our predicted value is higher than this 66.8. So if we want to find the residual, or the difference, we're going to take the observed minus the predicted. Or that's 66.8 minus 70.02. And this is going to give us a negative 3.22.